Hello students, welcome to my YouTube channel UPSU Technical Center once again. Today's subject is power electronics. Topic is step down chopper. Initially, I have covered this part of this chopper. You can see over here. The first thing I have discussed what is chopper, meaning of chopper. Next area of application, then the classifications. Before the classifications, we have already discussed AC link chopper, DC chopper, and the last one, the step down chopper and step up chopper. These will be the two part of a chopper. This is classified in two parts, step down and step up chopper. Step down means it will step down the voltage, that the voltage level will be less. As per the supply voltage is the 150, it may be 100, not that it is always 100. 150 step up, the voltage is 200, is not that it will be 200 all the time. As per this is a very short video, so without wasting the time, today I will start step down chopper. The left side here is this, the voltage level is DC, and the voltage level, suppose this is VS. Okay, this is the VS, and this is a switch, and this is chopper. Write down CA chopper, and this is diode, but this diode is used as freewheeling diode. Okay, next it is a inductor L, and this is load. This is load. Okay, so and the right side, this is the waveforms. Initially this is the input voltage, this is the input voltage. Okay, and this is the output voltage. You can write down V naught, and this is the output current, that will be the I naught. And the here is the pulses, or you can say switch on and switch on states. This is the switch on period, we can write T on. I will discuss one by one. This is the switch off period, this is T off. I will discuss is at every point. Okay, so first of all, suppose when the switch is closed. Okay, so we consider, suppose the switch is closed. What will happen? When switch is closed, the supply voltage will connect to the circuit, and the red lines show the direction of power. You can say the direction of current. So this is the path of current, you can say, when the switch is closed. Look at here. Here is the inductor. So you know it will store charge. So when the current will flow through this, the inductor will be charged, and this will be the polarity. Okay. So here is also mentioned the polarity of that minus, and this is plus, and this minus, and this is V0. Here the V0 voltage across the inductor and load. Load may be anything else. I will not interested to discuss about this. This is load. So across these plus minus, the voltage is G0. So this blue line shows the input voltage. This voltage is Vs, and you can say this value is Vs, and it is fixed. As our switch, here the chopper as a switch is switch on and switch off, switch on and switch off. T on period, this is the switch on period. At the switch on period, will get some voltage, and at the switch off period there will be no voltage. Why? Because the switch on period, the current will flow through this path. As the current will flow through this path, there will be some voltage across inductors, there will be voltage across load, and that will be the total voltage across V0, and this V0 will be reflected. So we can draw the curve, for the V on period, that is the T on period. This is the voltage you get. And when the switch is off, when the switch is off, suppose when the switch is off, I have shown this to this part. Now the switch is off. So when the switch is off, so here the inductor will store charge. We know this inductor will store charge. So as we know, the inductor will not decay the total charges at a time. It will take time to charge, and here the polarity of the voltages will reverse. It will become minus and it will become plus. Then then as it is switch is open, chopper is off, so the voltage across this inductor, as we know, the charge of the inductor will release through this path, and I can see this path through this blue line, through this path, and it will flow through this way and it will come to the point. So this is the path of the current. Now when the current will flow through this path, it will flow through this, which is it is flow through this diode. This diode is known as freewheeling diode or feedback diode, because as the switch is off, there is no way to flow through the current through the switch, so there will be only one path will be there. So that's why it is called freewheeling diode. And the important of this diode to carry the current, the carry the current, that means the current through the current of the charge of the inductor, the stored charge of the inductor will will release, and this current will flow through this diode. So that time there will be no voltage, because it is only discharge the current, so there will be no voltage. Next, when the switch is on once again, then you will get the voltages, and this will again at the as before. Next it will off, next it will on, next it will off. So this is the V0 voltage waveforms, or you can say this is the voltage as a chopping form. So that's why it is called chopper. Here the output voltage is in this pattern. Now what will be the value of current? So we can use the black color. So when the switch is on, the current will flow through this path. So current will flow through this path. That time the current will increase, and this current will increase through this path. Afterwards, when the switch is off, then current will flow through the diode. That means it will discharge. So that means at the T on period, current will increasing, at the T off period, current will decreasing. So this is the way of presentations of the output current. And here the limit of this value, initially it is called I0 mean. I will discuss in another lecture, and this is I0 max. So this is the path of current. Okay, next important things I will discuss, the duty ratio alpha. Suppose here the output voltage V0 equal to how much? V0 will be there when the switch is on. V0 will be there when the switch is on. So you can write V0 equal to Vs into T on divided by the T on plus T off. Now here the summation of T on plus T off is called total time. So